everyone, we're going to write each complex number in exponential form, and these are two problems we're going to do. So for the first one, what we're using is Euler's formula. So we want to write it in exponential form. More specifically, write it like this, where you have your r. So we first have to write this in polar form, and recall that polar form is right here. So we have our a plus bi. In this case, this is 0 plus 1i. So to get our r, we're going to write a equals 0 and b equals 1. So basically r equals the square root of 0 squared plus 1 squared, which equals 1. And then for 1, we know that that's going to be, if you graph it, if you graph this, 0 is right here, and you go up 1. This is your imaginary axis. So we can tell right away that that's going to be 90 degrees. So our angle is going to be 90 degrees. So the way you would write it is 1 times cosine of 90 degrees, which we know is 0, plus I sine of 90 degrees, which is 1. And then just write it in this form, which is going to be e. 1 times e is just e, so e I to the 90 degrees, and we're going to write this in radians. So this is going to be 90 degrees equals pi divided by 2. Looks better, so let's write pi divided by 2, and that's your answer for that one. Okay, very similarly, we have this one. So our a equals 1, a equals 1, and b equals 1. So r equals the square root of 1 plus 1, which equals square root of 2. Now our angle, tan theta, equals b over a, or your angle equals tan inverse, or inverse tan of 1 divided by 1. And that's going to give you pi divided by 4, because this is in quadrant 1. So writing this out, we're going to write 1, or square root of 2, cosine of pi divided by 4, plus sine times pi divided by 4, or sine of pi over 4. And that equals square root of 2 e raised to the I power times your angle, which is pi divided by 4. And that's your final answer. Let's put the I here. That's it. Thank you. Have a nice day. Bye-bye.